Hello students, hope you are doing well there, and this is the course on financial mathematics, and now this is the audio clip for lecture 2. So in lecture 2 what we are going to learn is futures, options and put call parity. So I request you to, when you read the PDF file of lecture 2, kindly open this audio clip so that you can understand line by line what you are going to learn from that PDF. So the very first thing, that futures we are going to learn, and let us start the lecture by introducing that. So in the previous, let me recap it. In the previous lecture we have studied forward uh, contract and how to price it, but earlier we have also studied that forward and futures are alike, they are similar. So in this audio clip, in this lecture, I'm going to tell you that what are the key differences between two. So the futures, on the first page of lecture 2 you can see the definition. Just like a forward contract, a future contract involves the delivery of an asset at a specified time and price. So the same like in forward also, there are two parties and they agree to buy or sell an asset at a specified time and price. So then what is the problem in this forward and future? That since it is a zero sum game, we have studied in the previous lecture. So the profit of one party is always the loss of another party, and the party who is assuming to go into the loss, he may default. He will always, there is always a risk of default by the party who is going to suffer a loss. So then how will you guarantee that at the end of the time the contract will be exercised? Because if someone is going into loss, he may not exercise the contract. Then what is the benefit of this, all this? So what is the, how will you guarantee, how will you make sure that whether he is suffering profit or he is suffering loss, he has to exercise the contract? So since on the second page of this lecture 2, if you see that future contracts are designed to eliminate such risk. It is done in futures that they cannot default. So how it is done, that if you remember that forward contracts are over the counter traded. I mean, you go to some party or some party comes to you and you can set your own rules and you can define a contract and you can do that. But in futures they are exchange traded. So the role of exchange in this futures contract is prominent. I mean, they set a set of rules and regulations and so many things, and that's how they manage to eliminate the default risk. So we'll learn how do they do it. So suppose in the very first we assume that time is in discrete manner. I mean, tau length, with this step of length tau. So usually suppose it is in days, so 1 day, 2 day, 3 day, 4 day, and s of n, if you represent the stock price by s of n, n is from 0, 1, 2, that you can find on your page 2 of lecture 2. So s of 0 means initial time, s of 1 means stock price after 1 day, s of 2 means stock price after 2 day, and so on, right? And now future price of future contract I'll denote it by small f. Recall that price of forward contract we have denoted it by capital F, right? So but price of futures we will denote it by small f. So in the same way, like f of nt, so n is 0, so it would be f of 0t. I mean, the futures price is at time t equals to 0, and f of 1t, that means future price at time t equals to 1. So in this way we can divide, but you can see here we are saying so many futures price. I mean, fnt, f0t, f1t, f2t. Why is it so? I mean, in forward it was only f of 0t, capital F of 0t, if you remember, right? So why is it so? I'll explain it, right? So what happens in future, this third page of your lecture to PDF, that according only F0T is known, right? F0T is known, of course, because you know that okay, what will be your futures price is at time t equals to 0. So, but it what about the other futures price, like for n equals to 1, n equals to 2, n equals to 3 and all, right? You don't know. So these are random variables. So technically, what is the difference that I have written on this page number 3 of lecture 2, that at time t equals to 0 there is a no cash flow. However, there are cash flow during the remaining lifetime of future contract. So means in futures initially there is no cash flow, there is no exchange of cash, but as time passes, at every step of time there would be some cash flow. In forward, you have seen there is no such thing, there is only one cash payment, and which is at that end time capital T. So that I have written it here, you can read it. So the idea is, though by definition futures and forward are same, but key point one, that forwards are over the counter traded, futures are exchange traded. So futures are designed in such a way so that your risk can be eliminated, that okay, no one should default the contract, whether he is making profit or he is making loss, it doesn't matter. So that is why futures are designed in such a way, and there is cash flow during the lifetime of future contract. So still, if it is not clear, I'll explain very shortly an example how this future payment is done. So future contracts involves the random cash flow, and that random cash flow is called as marking to market. Just a notation, I mean just a word for it. And what usually happens is that at yeah, this is important. So make sure on page 3 last paragraph, that what usually happen is that at each n equals to 1, 2 and so on, the holder of long position will receive or pay. So it depends on whether he'll receive or pay. It depends on this quantity f of nt minus f of n minus 1t. So if this quantity is positive, he will receive this much amount. If this quantity is negative, he will pay this much amount. So make sure, if fnt minus fn minus 1t is a positive, he will receive this much amount. If it is negative, he has to pay this much amount. Of course, in short position, you just reverse the case. Receive by pay and pay by receive. So for the case of short position, the reverse payment is applicable, and we know that of course at final time the price of future contract will be the stock price at time t. So then because it is a exchange traded contract and it is regulated one, so now let us learn little something about what are the practical regulations happening in the exchange traded market for trading the future contracts. So first is of course for eliminating the risk, every investor of the future contracts has to pay a minimum deposit that is called initial margin, so that if he or she wishes to default, the exchange can pay the other party from that initial deposit. So initial margin is that the minimum deposit that an investor has to pay to the exchange. So for long position, this fnt minus fn minus 1t is added if it is positive, and if it is negative, it is subtracted. So again, this is like not very clear what is added, what is subtracted. So we are coming very soon to an example, and there it would be more and more clear. So for short positions, of course, exactly reverse happens, and you can also see the book for this clarification of these definitions and notations, and you can mail me also, and if you have any doubt. So the idea is following observations are made from above. So what are the observations? That any amount is excess of initial margin can be withdrawn by the investor. So exchange has fixed, okay, that this much amount you have to deposit. So by any time, if your total deposit is exceeding that initial amount, you can withdraw the excess amount. Suppose exchange is saying that you deposit minimum 10 rupees, and now your investment has become 15, so you can withdraw 5 rupees, but 10 has to be there. So, but if it is falls below a certain level called a maintenance margin, the exchange will issue a margin call, and that we will not discuss in detail. It is little deeper. So now we have understood that, okay, investor has to some deposit minimum amount, and there are cash flow at every time in futures contract. So now these all the things we will learn by the example, and that I'll record in separate file, so I'll send you. Thank you. So hello students, welcome again. This is the second part of the audio clip for lecture 2. So we understood the definition and the practical regulations for future contracts, and now we are going to discuss all these things via this example. So there is an example given in this lecture 2 PDF. So suppose that initial margin is set at 10% and maintenance margin is set at 5% of the future price. So if you see the table, and this table, make sure it is for long position. So if it is for short position, everything will be reversed. So I'm not going into for the short position. The table is for long position. So n is the discrete step, time step. So 0, 1, 2, 3, 4 and so on. F&T is the futures price, the cash flow at every time basically. So cash flow at 0 is 140, cash flow is at n equals to 1, 138, and 130 and 140 and 150 and so on. So now if you see the cash flow, right? So cash flow 140 is the opening. So there is no cash flow. We all know that at n equals to 0, there is no cash flow in futures also and in forwards also, right? So margin, of course, there is no cash flow. So beginning of the day, margin 1 is beginning of the day. So there is 0. Payment, why this? Because you have to pay the initial deposit of 10%, and it is said in the example that initial margin is set at 10%, right? So 10% of 140 is 14, so you have to pay the 14, and by the end of the day the margin to that is 14 rupees technically, right? So if you come to 1 and equals to 1, this is 138. So for long position you have to subtract fnt minus fn minus 1t. So means latter one minus the previous one, so it is minus 2, and it is negative. So if it is negative, you have to pay, right? So 14 was there and it is minus 2, so 14 minus 2, it becomes 12, right? So it becomes 12, and 1 and 12 is more than 5%, because the maintenance margin is 5%, right? So more than 5% of 138. So 5% of 130 is even lesser, right? So there is no payment you have to make, and the end of the day it will again be 12 rupees. So n equals to 2, if you come, this is 130, right? So 130 minus 138, of course latter one minus previous one, right? It is minus 8. So the end of the margin was 12 in the previous, so 12 minus 8, it is 4. Now it is a problem, because 4 is not even lesser than 5% of the 130, right, maintenance margin. So you have to pay, right? So he has to pay the 9 rupees, so you have to maintain again the initial deposit of 13. So it was 4 and minus 9, you have paid 9, so 4 plus 9 is 13, and 13 is why you paid 9, because you want to make the 10% of 130. So that's how the end of the day margin 2 is 13 rupees. So now here it starts increasing. So now you see 140 minus 130, that is 10. So 13 was in the previous step. So 13 plus 10 is 23, right? So margin 1 beginning of the day is 23. But the problem is, you don't, as I said, anything access to the initial margin you can withdraw it, right? but and you need to, because the price of future contract is 140, so you need to put only 14 rupees, so you can withdraw 9 rupees. So from 23, if you withdraw 9 rupees, it will be 14, and it is enough. I mean, 140, 10% of 140 is 14, right? Similarly, in 150 case 4, I mean n equals to 4, it is 150. 150 minus 140 is again 10, and last it was 14, so 14 plus 10 is 24. So 24, again you have to maintain only 15, because 10% of 150 is 15, so you again withdraw 9 rupees and it becomes 15. And that's how at each time step this cash flow is being done. And the minimum deposit is always with the exchange, and any of the party cannot uh, default. If it defaults, the other party will be paid by that initial margin deposited to the exchange. So you can understand it via another example in the book, and from other sources also. So if you feel any difficulty, you can contact me, right? So very briefly, I'll tell this theorem, that if the interest rate R is constant, then forward price and future price at n equals to 0, of course that would be equal, because at n equals to 0, almost all the properties they have are similar. So here we conclude our discussion about forward and future, though it is very short. What we discussed about forward and future, they are very large topics. But yeah, so now we are going to discuss another derivative security, and that is called options. So options we have already studied a little bit in our previous lectures. So let me recall very briefly that what are the options. That one party agrees with the other, but the buyer of the option does not have any obligation to exercise it. If he wants to exercise it, he can. If he doesn't want, he may skip the exercise of the option. But he has, in such a way, he has some leverage. So for that leverage, he has to pay some price initially, and that's the difference, right? In forward, there is no price payment initially, but in options, he has to pay some price initially, and that price is called option price. So they are European type, American type. So, and then they are of call, they put, right? So you can all revise it from your previous notes, or from book, or from anywhere. So I'm not going into detail again. So you should recall the definition of European call, European put, American call, American put from your previous lectures or book. So payoff is basic technically what you get at the end, right? So the buyer of the option, what do you get? So maximum of st comma 0, st comma minus x comma 0. So st, you know that this is the price at final time. Capital X is the strike price. Strike price is nothing but at what price your deal is done. So that is called strike price, and this we denoted by capital X. So at the price, suppose at the end, right, European call. So at the end, the price is suppose 100 and your strike is 90. So 100 minus 90, right? And why it is maximum of this and this? Because what is this? I mean, either you, and suppose ST is less than, so you don't exercise it, right? So your payoff, I mean your last payment is 0. So if you are in profit, you will exercise it. If you are not in profit, the buyer of the option will not exercise it, right? So European call, European put, and capital T is the final time, of course. So our aim is to establish some general properties and bounds. So bounds we will discuss in the next lecture, of course, not in this lecture, but some general properties we will discuss here only. So the first is options are freely traded. I mean, there should not be any limitation or something that we cannot buy this much and we cannot buy 100 and we cannot buy 200. So they are freely traded, right? So, and then these are the notations on the next page. You can see that this CE and PE, CE for call, E for European. So CE and PE are the price of European call and European put. Similarly, C for call, A for American, CA and PA are the price of American call and put. And fourth is lending and borrowing interest rate is same, and This is not happening in the market, right? But for the simplicity, we assume it here. Suppose I borrow from bank, they charge higher interest rate as if I lend them. Of course, we all know, right? But for the simplicity, we have assumed here that lending and borrowing interest rates are same. If it is not, the things will be more complicated, right? But here we assume that both are same, right? We assume that continuous compounding is used. So we all know that, okay, what happens to continuous compounding, right? We have studied it in very detail. So now we can observe that what will be the gain of the buyer, right? So gain of the buyer is st minus x plus means that maximum of st minus x comma 0, and this he is going to get minus ce e to the power rt. Why the ce? Because he has paid a premium of ce, right? So over the time it has become ce e to the power rt because continuous compounding is used, right? So whatever he is getting after 1 year or at the end of the time, and he has paid this much amount ce to the power rt. So total profit or total gain should be calculated by subtracting these two amounts, and same for put option. So technically, suppose I'm giving you a very brief example. Suppose you paid option price of 10 rupees. So 10 rupees will be 10 into e to the power rt after capital T time, right? Because after 1 year, suppose, so 10 into e to power r into 1, this will be your money after 1 year, right? So this you have already paid, and what payoff you are getting? St minus x to the power 0. So suppose st minus x to the power st minus x maximum of st minus x comma 0, that is suppose 50 rupees. So technically your profit is 50 minus that 10 e to the power r 1, right? So that's how it is related, so you can understand. And we can note down that the maximum loss for the buyer is only that premium he has paid, whatever the premium he has paid, right? Suppose he wants to exercise the option, he can exercise. He doesn't want to, he should not exercise the option. And the only loss is that whatever the premium he has paid to the other party, that will be gone. So at the end of the lecture, we'll discuss very briefly that how, if you can relate the price of put and call options. So this is the question 1 that relates the price of European call and put options, but make sure the stock pays no dividend. So in case of dividend, it will be different, of course, right? So this is the relation, and proof will not be doing here, so you can see in the textbook, right? So this is called put call parity, right? It is very important. We'll see in the next few lectures why it is important and where we can use it. So with this we conclude this lecture, and so at the end of this lecture you must be able to explain that, okay, how the future contracts are designed, how are they different from forward contracts, and how the cash flow is done in the future contracts. So thank you so much, and very soon I'll send you this audio file for lecture 2 and lecture 3 with its audio file. So thank you.